Hey everyone, welcome to this deep dive into Python functions. Functions are essential for writing reusable modular code. In this tutorial, we will explore function definitions, parameters, return values, and advanced concepts like variable length arguments, scope, nested functions, and recursion. We will also classify functions based on their purpose and behavior and include plenty of code examples. Let's dive in. A function is a named block of code that performs a specific task and can be called multiple times. Functions improve code organization, readability, and reusability. In Python, we use the def keyword to define them. Let's start with a simple example. Let's create a basic function definition. Say hello, parentheses, and after that a colon, print hello. Now we have defined our function. First line defines a function named say hello using def with empty parentheses and a colon. Second line prints the string hello inside the function, so you can just call it by writing its name, since this function takes no inputs and returns no values. We will see them in detail. So we typed say hello with brackets here, but blank. So we can call it like this, simple as that. Now, if I run it, it says hello. So we defined our first function. Parameters are variables defined in a function's parentheses that allow it to accept inputs, called arguments when called. There are several types of parameters: positional, default, variable length, and keyword based. Let's start with positional parameters. Let's define a function named greet user. So this will print a greeting message for the user by taking inputs as parameters. That's what to expect for the parameters. So we can write name and greeting message. So one of the parameters is name, the other one is greeting. So this one, the message, this one. Now let's type a colon, then break a line. Let's write print a formatted string, double quotes, greeting, and name. So it's simple. And when we want to call it, so we want to call it now, we have to use these parameters. Here, name and greeting are positional parameters, meaning the order of arguments matters. Parameters act like placeholders that get replaced by arguments when the function runs. You can also use keyword arguments, but let's call it normally. Let's type greet user Jim hello welcome. It will print out hello, comma, welcome, comma, Jim. If you want to specify these parameters in a better way, like this, greet user name equals Bob and greeting equals hi. Let's run it. It says hi Bob. So the position now does not matter. Also acceptable, since you explicitly define what are your values. So the function knows which one it will assign to. And when you run it, you get this result too. The other one is the default parameters. So default parameters have predefined values used if the caller omits an argument. They are great for optional inputs. Non-default parameters must come before default ones. Here's an example. So let's keep this function and write greeting hello. Now we keep their same. Let's say greet user Bob, greet user allies, and greet user allies hello. You can also define it explicitly, but since I take care of the order, we don't need here. Let's print it all. It says hello Bob, hello allies, hello allies. If I change this one to hi, it will print out hi allies for this one differently. If no greeting is provided here, it defaults to hello. Default parameters make functions more user-friendly by reducing the need for repetitive arguments. Sometimes you need a function to handle a variable number of arguments. Python provides args for positional arguments and EW args for keyword arguments. Args collects extra positional arguments into a tuple, while EW args collects keyword arguments in a dictionary. Let's see both in action. So let's define another function named as some numbers with args. You will type a star symbol before it, like this, args. Now let's type total equals 0 for num, so for numbers in args. This function will print out the sum of all numbers given as input to args. For num in args, total plus equals num and total. So now let's try it. Print will print out what returns from this function. So print out what returns from this function. Since total is a variable too, you just have to write it inside print. So you will call it inside print. We'll call it from print function. Let's write sum underscore numbers 1, 3. Run it. It says 6, so we are right. Now let's also print numbers 10, 20, 40. Let's print it out. And it says 100. In the first line, we defined some underscore numbers with args to accept any number of positional arguments. The second line initialized total to 0. The third line, we iterated over args. It's a tuple here. We call some numbers with 1, 2, and 3 here with 3 parameters and here with 4 parameters. Now let's try for EW args. Define another def print details with 2 stars this time. W args and write for key. You can traverse dictionaries like this in EW args dot items print key value. So call it outside tails. Name equals Bob. Age equals 20. and the York. If we print it, we can see all of these parameters. So name is Bob, age is 20, and city is York. In the first line, we defined the function. Second line, we iterated our key W args, a dictionary using dot items. In the third line, we printed all key value pairs we provided as inputs to this function. In the first example, args lets us sum any number of inputs. In the second, EW args lets us handle named arguments dynamically, like a user's details. These are powerful for flexible function designs. Now let's learn about return values. Return values are how functions send the results back to the caller. The return statement specifies what a function outputs. A function can return any data type, numbers, strings, lists, or even multiple values. If no return is specified, the function returns none. Let's look at a function that returns multiple values. Let's define the function. So say def divide and remainder a comma b colon quotient equals a floor division by b and remainder equals a modulus b. Let's return quotient and remainder. If I want to take it, I need to unpack it. So let's write qr equals divide and remainder 10 comma 3. Let's call this function and assign results to q and r. After that, print f quotient q comma remainder r. And let's run it. After we run it, we can see quotient equals 3 and remainder equals 1. So, how this function actually works? Here, the function returns a tuple, which we unpack into q and r, because it returns multiple values. Return values let you use a function's output in other parts of your program, like calculations or conditionals. You can also return early to exit a function, for example, if an input is invalid. Now let's take a look at scope and nested functions. Scope defines where a variable is accessible. Variables inside a function are local and only exist within that function. Global variables, defined outside, are accessible everywhere unless shadowed. Nested functions are functions defined inside others. Let's define another function, and inside parentheses, write a parameter named message, and define inner function, and print f inner message. This one is a function to print it as uppercase to not confuse with anything else. It's a built-in string function. So let's call the inner function inside other function and call the other function outside. Print, make it print hello. But so far, we defined other function with a parameter message here. Define inner function inside other function. Print message in uppercase using string.upper and so message.upper. As you can see here, the inner function is a utility function that accesses message from the other scope. It's only callable inside other function, keeping the code organized. So you can't call inner function from outside. And let's print it. It says inner hello. Let's try to call inner function here. And as you can see, it says name inner function is not defined because it's only defined within other function. So we will see variable scopes in detail in a feature video, but this time you can see you can write inner functions, a new function. Now let's talk about recursion. Recursion is when a function calls itself to solve a problem by breaking it into smaller parts. It needs a base case to stop and a recursive case to progress. Let's calculate a factorial recursively. Let's define a factorial. Define a factorial n as the parameter. If n equals 0, turn 1. Else, turn n multiplied by factorial n minus 1. And let's call it print factorial 5. Prints out 120. It computes for factorial 5. Let's think it. For factorial 5 computes 5 multiplied by, because the case he says if it's not equal to 0, it will return n multiplied by factorial n minus 1. So it says factorial 5 minus 1. What's it? So it's 4, goes like that. Then it will jump here because it's a function call. Will jump here and it will run for this one. Will go again to this function and it will again return n multiplied by factorial n minus 1 because it's not equal to 0 yet. So it becomes 4 by factorial 3. It goes like that, 3 by factorial 2 and 2 by factorial 1 and 1 by factorial 0. For factorial 0, it returns to base case. So it comes here and it returns 1. So since it's a base case and this one else clause is the recursive case, it returns 1. So what value you expect here? It should be 1. Now it will go up. So it's 1 multiplied by 1 equals factorial 1. So it will become 1. 1 multiplied by 2 will be equal to factorial 2. So it will become 2. Then it will become 6, then it will become 24, then it will become 120. So the result is 120. Without recursion, you can do it using for loop. You should first keep a number, a variable to track it, but you should not assign it to 0. You should assign it to 1. So after you assign it to 1, you will multiply by new numbers in the for loop. So if you want to compute factorial of 5, you will start from 1 and multiply numbers until 5. Until so far, we have learned about functions, parameters, return values, and advanced concepts. If you like the video, please do not forget to subscribe to the channel. Thank you for watching and have a nice day ahead.